See, in the first normal form, what we have done. So, first normal form rule is what? See, simply you can remember this table, then you can understand everything easily. So, first normal form. So, there is no repeating data groups. So, it should not allow repeating data groups like multi-valued columns should not allow. So, instead of that, we are decomposing it. If the, for example, if you take the course, the student can do multiple courses at a time, like C, C++, Java. He is doing 3 courses. We cannot insert 3 courses in one column. Okay, we should not. That is, if we are writing like that, means that is not following the first normal form rule. So we should avoid so we should write student ID and course name separately. Student ID, course name. So student ID, course name is Java. Then student ID, course name. Student ID is 1, course name Java. Student ID 1, course name C. So student ID 1, course name C++. So in that way we should write, means, so one column having only single value. You should not store multiple values. So that's about the first normal form. Second normal form means there is no partial key dependency. So we should not allow partial key dependency. That must be a fully dependent on the candidate key. So that what are the attributes we have, non-primary attributes, that must fully dependent on the candidate key. So if it is fully dependent on the candidate key, that means that is following the first normal form rule. So no transitive dependency. This is regarding to the third normal form. No transitive dependency means here we have transitive rule, right? A turns to B, then B turns to C, then I can write A turns to C, right? So it should not be like that. You should not use transitive dependency here. So if you are if the table is don't have any transitive dependency, then that means it third normal form. It is using third normal form. It is in the form third normal form. Okay. Next thing is Boy's code normal form. It is like a third normal form. So every normal form, if you are coming to second normal form, it must follow the first normal form. Okay. If you are coming to third normal form, the third normal form must follow the second normal form. Then you are adding this rule, no transitive dependency rule, like that. So if boys co-normal form is, that is also follow the normal form rule. Then here the condition is what? Reduce the key dependencies. Reduce the key dependencies. Okay. So boys code normal form means we should remember it is a non-trivial functional dependency. Non-trivial functional dependency. So there is reduce the key dependencies. Okay, we should reduce the key dependence. Then it is in the boys code normal form. Here every functional dependency, like our functional dependency, like A turns to B, A determines B, or B depends upon A, then A is to be the super key of that particular table. The A should be uh, super key of that particular table. Okay, here super key means what? Group of single or multiple keys identify the rows. Okay, identify the rows. Group or single group of single or multiple keys used for identify the particular row uniquely. Okay, that is called super key, right? So here I will explain with one example, then you can understand this Bayes code normal form. So it reduces the key dependency. Key dependency, we should reduce the key dependency. See, I have one table I created here. This is one table, so that contains student ID and the subject and professor, and here the student IDs not 1 2 2 3 and 4. Here duplicate IDs there, and the subjects SQL, Java, C++, Java is here. Professor, uh, Ramu, duplicate here, that means he is teaching. multiple subjects. So the student taking multiple courses. Okay, one student, Gina, two student take it multiple courses. C Java he has taken and C++ on it. When multiple professors taking one course or multiple courses done by the one course teaching by the one professor. C Java is teaching by the Ramu professor. C++ is teaching by the at Kranti professor. Okay. See that means what here one student enroll for multiple subjects. So one student enroll for multiple subjects. Then there can multiple professor teaching one subject, multiple professor teaching one subject. Okay, multiple professors teaching one subject. Uh, okay, and for each subject of professor assigned to the student, each subject of professor assigned to the student, then there are necessary conditions in the table. There are the necessary conditions in the table. What are the conditions? One student enroll for the multiple subjects. One student enroll for the multiple subjects. There can be multiple professors to teaching one subject, and for each subject a professor assigned to the student. These are the necessary conditions in the table. In that case, the tables are normal forms satisfy the except BCNF. See here, I decomposed this one table into two tables. See here, student ID is the, what is student ID here? Candidate key, super key. Okay. Here by using that I differentiated. So actually this should not depend on the IDs, right, keys, right. So that's what the DCNF. That means DCNF condition is what? Reduce the key dependency. So non-trivial functional dependency should be there, and that means what? So if I have the A tends to, if I have A tends to B dependency, functional dependency. Okay. So A attribute determines B, A attribute determines B, B depends upon the A. So this is the non-prime attribute that depends upon the A attribute, the prime attribute. Okay. Now, here A should be what? A should be super key. A should be super key of that particular table. So if it is a table, the relation, if it is one relation, so here A is the, so now how can I decompose it? How can I decompose it? Okay, here SID, and that means the student ID. The student ID and subject columns are prime attributes. What are the prime attributes? Student ID and subjects. These two are prime attributes. Student ID and subjects are prime attributes. Professor depends on the subject. Here professor is what? Non-prime attribute. That professor depends on the subject. Okay, that professor depends on the subject. Here such is the prime attribute. So here subject is a prime attribute and professor is a non-prime attribute. So which is not allowed in BCNF, which is not allowed in BCNF. So I want to decompose it. How I can decompose it here? So I can decompose this one like this. So student ID, professor ID, and here I added professor ID. See here, I added professor ID. So here professor ID is what? Super key of the table. So that means it removes column functional dependency of the attribute. It removes column functional dependency of the attribute. Okay, in this way I can divide, and that means I can decompose the table. So student ID and professor ID I added, and professor ID I have added here, subject and professor. So professor depends on the subject type, so I divided here. That means Here we are removing column functional dependency of the attribute. Column functional dependency of the attribute. Okay. So by doing this, we are removing non-prime attribute functional dependency. Okay. Non-prime attribute functional dependency we are avoiding here. That's what about DCMS. Okay. So next, fourth normal form, it follows the rules of the third normal form. So and here no multi-value dependency. No multi-value dependency. We have multi-value, so there should not be a dependency. And fifth normal form, no joint dependency. So in real time also we can use till the voice node for normal form. Here if you are doing decomposition of the table, till this rule is enough. Okay. And these two we are using. So and we should know about this two also, and fifth normal form and with this here. Okay. And first normal form, second normal form, third normal form, and boys code normal form. Third normal form completed, right? Okay. Next, boys code normal form we completed now, and fourth normal form. Next, we can discuss about fourth normal form. A relation is said to be fourth normal form. See ma here, just you can see the rules. Okay. A relation is said to be a fourth normal form. Okay. If it is in the third normal form, relation is what? Third normal form. It is in third normal form, and no multi-value dependency should exist between the attributes. Here, main thing is what? No multi-value dependencies. No multi-value dependency should exist between the. Okay. So in some cases, multi-value dependencies may exist not more than one time in the given relation. So rule of multi-value dependency. Okay. Next, so multi-value dependencies here. Suppose there is a bike manufacturing company which produces two colors, white and black. White and black. Each model we are noting the each model every year we are noting down here. We are noting down here. Okay. Bike model, manufacturing, color are the attributes. So now this is the data. So here column color, manufacturing year, dependent on the bike model. These two attributes depending on the bike model. Okay, bike model. Next, and independent of each other. These three are independent. Okay, but the manufacturing year and color are depending upon the bike model. In this case, the two columns can be called as a multi-value dependent on bike model. Multi-value dependent. These two are depending on the model. These two are depending on the model. These two, year and color, depending on the model. So in this case, the representation, this dependency is shown below here. See here. So the bike model and manufacturing year. The bike model color. In this way, we can decompose it. Okay, bike model, manufacturing is one table, and bike model color is one table. We can divide like that. We can decompose like that. Okay. Next, fifth normal form. So the fifth normal form is related to joint dependencies. Fifth normal form is related to what? Joint dependencies. A relation R, that means one table we have, is said to be in the fifth normal form. Means if for every joint dependency, JD means what? Joint dependency. join of R1 comma R2 comma R3 comma R4 comma and so on Rn. We are joining the multiple tables, okay, that holds over the relation R. One of the following statement must be true. Here one of the statements must be true, either it is first, second or third. So R of I equal to R for some I. So the joint dependency is implied by the set of those functional dependency over relation R, which is the left side is the key attribute of R. So it is left side of key attribute R. Okay. The note here, one note is here. So if the relation schema is third normal form, the relation schema in third normal form, and each of its key consists of single attribute. If each of its key consists of a single attribute, we can say that it can also be in the fifth normal form. Okay, the third normal form, the relation schema is in third normal form, and each of its key consists of single attribute. We can say that is also in the fifth normal form. Next one, a joint dependency, JD, joint dependency like R1, R2, R3 and so on Rn is said to hold for the relation R if R1, R2 and so on Rn. Okay, so this decomposition is a lossless joint decomposition of R. Okay, next, the when a relation is fourth normal form, when a relation is in the fourth normal form and decomposes further to eliminate the redundancy and anomalies, we are eliminating redundancy and anomalies due to insert or update or delete operation. There should not be any loss of data. We should not create a new record, and when the decomposition tables are rejoined, so like joins, so that is the condition we are following in fifth normal form. Okay, next to domain key normal form. Here a domain key normal form keeps constraints that every constraints on the relation is global sequence of definition of key and domains. Okay, so the domain key normal form keeps a constraint, okay, that every constraints on the relation is logical sequence of definition of keys and domains. Okay, so that follows domain key normal form. If it is sixth normal form, so here sixth normal form is what? A relation is said to be sixth normal form is such that the relation R should not contain any non-trivial joint dependency. Your non-trivial joint dependency should not be there. Okay, so these are the rules for the number of normal forms. Okay, here we need to know about some important points, so some key points of the normal forms. So those are, see, first one is BCNF is free from the redundancy. If you are following if you are in BCNF means that means you are free from the redundancy, duplication of data. If the relation is in BCNF, okay, then 3NF is also satisfied. You know that if you are following if you are in BCNF means that is 3NF is also satisfied. If all attributes of relation are prime attributes, if all attributes of relation in the relation are, if you are, all attributes are prime attributes like employee ID, Aadhaar number, some email ID. So these all are primary attributes. Then the relation always in normal form. So the relation in the normal form. A relation in the relational database, a relation in a relational database always and at least first normal form. First normal form. See here, whatever you are created tables, those are all are in which format? First normal form. So multiple values we are not storing. Okay, we are storing one value for each column. Okay, so binary relation, a relation which only two attributes. Binary relation, a relation with only two attributes. So student ID, student name is always be in your BCNF. Okay, that should be always in a BCNF. If a relation has only singleton candidate key, every candidate key consists of only one attribute, so then the relation is always in second normal form. Second normal form means what? There is no partial functional dependency. The point is what here? The relation has only single candidate key. The relation always in second normal form. Okay. Sometimes going for BCNF form may not preserve the functional dependency. It not stores the functional dependency. In that case, we can go for BCNF only. If the last of functional dependency is not required, till a normal form only. So there are many more normal forms that exist after BCNF, like fourth normal form and more. But in real world database systems, we generally not required to go beyond the BCNF. Okay. Still BCNF, that's enough. We have lot of problems regarding to normal form. What is the highest normal form we need to find? These problems we need to practice now. So next we have dependency, preservation, decomposition. This will next. Okay, and now I have one question. So here I have one case. So important interview question. So I have multiple tables. Employee table, employee salary table, and employee some department table. Okay, employee profile table. So we have so many tables regarding to employee. Okay, as now I'm working in our organization. So Vardhaman organization I'm working now, right? So if I get any job in other side, if I leaving this college, so they are should delete my data. Okay, so my data is available in every table. Okay, employee table, employee salary table, employee profile table, department table, every table. So if they want to delete my data, first they can delete this table and they can delete on this table. Every table they should delete, right? So instead of that, if I delete the data from employee table, so employee salary table data should delete, employee profile data should be delete, and employee department table data should be delete, right? So how can I delete that? How can I do like that? So that is the case. They have asked how to write that query. Tell me how to write that query. So if I want to delete one row from one table, that should affect on that related tables. How can I do? What is the query you are writing? I explain with a clear example. Yeah, ask me like. So in that case, I used this syntaxes to create. I created two tables: employee table, employee salary table, and employee ID, employee name. Here employee ID, employee salary. So here the data is Siva and Ramu. Okay, and ID is 1 and 2. So here EID is primary key, and here another table, employee salary table, EID is foreign key. Okay, that EID points to the EID of employee, that is primary key. Okay, now how can I perform delete operation? If I deleted this row, so what is the related data available in other tables, that is also should delete. So in that case, I created these two tables. So this is the syntax to create a table. Already you know how to create the tables, okay, and how to do some operations. Like create employee table, I created employee salary. Two tables I created. So here in first table, what is the primary key? Employee ID is a primary key, and the second table, the foreign key is what? Foreign key EID that references employee. Which table it is references? Employee. What I'm performing? On delete cascade. If I want to do what I said here, that I need to delete. On delete cascade. Okay, this you need to remember. You need to on delete cascade. Okay, you have on delete update. These are called enforcing referential integrity constraints. Enforcing referential integrity constraints. So next, I create a department table. Department having uh, department ID, manager ID. So here foreign key is what? Manager ID. Okay, that refers to the employee tables. That means I created employee table. So on delete set null. Okay, so whenever if I delete that row, which one I referred as foreign key? Manager ID, right? Instead of manager ID, so this becomes a null value. So instead of 1, can store null, null. Okay, that is the meaning of on delete set null. These we can do. Remaining I am trying to do, but it's not executed. So these two we can do. Okay, on delete cascade and on delete set null. So I used queries. Already I executed. I have taken some screenshots also. See here, I created tables. So create table name. Here employee 55 is the table name. EID is integer and ename is char, and primary key is EID. So by using this syntax, I created one table. So I'm trying to insert two values here. One is ID and name, one Siva, ID name, two Ram. And another table I created, employee salary table. Here attributes are EID and eSalary. So that is float. EID is integer, and here foreign key I make EID is a foreign key that refers to employee table. On delete cascade, this one is important here. On delete cascade, if I delete one row from employee table, all other tables should affect. That means all the data should delete on other tables also. That is the okay. Next thing, so in the second table I inserted employee ID and the salary. Okay, you know already the primary key foreign key relationship. So if you are if you have the data in the first table employee 55, then only I can insert the data into the child table, that is EMP salary table. Okay, how can I do it? So I return the queries. See here, I inserted data, select star from employee 55. So I inserted this data, employee ID, employee name. So second table, employee salary, I inserted data, employee ID, employee salary. Okay, so if I delete, I am performing delete operation in one table. Delete from employee 55 where EID equal to 1. Okay, I am deleting this row. That means first row, 1 Siva I am deleting in this employee table. Okay, so if I delete here, that should affect on employee salary table also, right? So is it affected or not? We can see here. I deleted, so I should display, right, to know about whether the elements are deleted or not. So I used to select query, select star from the employee salary. So only I have second element, means ID2 data, ID2 row only available, ID2 row only available. That means this data deleted. So this data is related to this data, so that data also deleted from the employee salary table. I performed this operation on two tables only, so you can check this same condition with employee salary table, employee department table. So create multi platform, is it what? Okay, so and other operation I performed, that one on delete set null, on delete cascade you have seen. So on delete set null, so what will happen? So on delete set null, if you are deleting one row from one table, that should affect on table, like what it is going to delete not available, but at the element that should be null. Okay, what is the query I need to write to do on delete set null? So create, while you are creating, this is also constraints where we can use while creating the tables, right? Okay, this is enforcing integrity, referential integrity constraint, enforcing to delete. Okay, all the tables. So create table employee salary EID integer result float and foreign keys EID reference EM5 on delete set null, on delete set null, on delete set null. So if I'm trying to insert this value again, because I already deleted, right, Siva value, so that's why I inserted in this table. Next, in the EMP salary table, I inserted one ID comma 10,000 rupees salary, and the second inserted to 20,000 salary. So now select from EMP salary. I have from EMP salary I have second ID. So who is having roll number, employee ID, to those data available, and select start from EMP salary. So if I, after inserting the data, so two values I inserted, right, the data is available. So if I perform any operation, delete operation, delete from EMP55 where EID equal to 1, the row will be deleted and the data should be null for the employee ID where ID equal to 1. See here. So if I perform delete operation, delete from EMP55 where EID equal to 1, means in the related table EMP salary the value of 1 is what? Null value. Wherever if you are trying to delete that value, we are setting the value null. So that's what query we have written, right? That part, that constant we have written here. On delete set null. If I delete the value, is going to be a null. Which value? Only foreign key what you have given there. So ID, right? So that ID value going to be a null here. So null means now you cannot see null here actually. So anything not available means default way it is null value only. Okay. So select EID e-salary from this table where EID is null. So null value. If I want to try to see only the null value, see here the 10,000 value having null value. That means we are deleted. Okay. So these two you should execute. Okay, these are very important queries. First one on delete set null, and second one is what? On delete cascade. On delete cascade means all data going to be delete, all the rows which are common to the table. Okay, and set null means if you are trying to delete, if you are performing delete operation on the row, so related rows are going to be null. Okay, that row value, which row value, on which value you are performing delete operation EID, right? So that value going to be null. We have seen here. Okay, this is the proof. Same queries, you note it down these queries and you should practice. Okay, first one and second one. Okay, before that you need to create these tables. Okay, I created only 2 tables. You create 3 or 4 tables. Next perform delete operation. Okay, then check whether it is working or not. Okay, so already I worked on that. So these are the examples. You can see same thing you can do in your labs. Okay, okay, all of you, thanks for listening the session. So remaining things we will discuss in the next class. Please be practice whatever the queries I'm saying important, and the remaining things remaining things also should practice. Okay, what are the things I'm saying very important? You must practice that queries, because these will interview and as well as you can face in the exams also. Okay, don't forget to practice your queries. So regarding to common queries, group by having so joins, especially join condition, they will ask in the interview. Join 3 or 4 tables, not 2 tables. Perform join operation among 3 or 4 tables. Okay, learn the join for the interview purpose. On your exams also they will ask questions on joins. Okay, these are very important for the database developers. Okay, that's all of you. Thanks for listening this session. We can continue in the next class. Thank you. We can leave the class now.